Hello and welcome to this video. This video is a continuation of previous videos where we left with the Warshall algorithms. So if you have not seen the previous videos on graph, or if you are unfamiliar to graphs is strongly recommended that you visit the previous videos, you watch them and grasp the basics of what a graph is and how do we create adjacency matrices and find the path lengths of different lengths. So we have seen the adjacency matrix. The main problem with the adjacency matrix representation of a graph is the memory consumption, because we declare that our adjacency matrix will be of ON square, where n is the number of vertices. Because as you have seen, we had defined max nodes as 100, and our adjacency matrix was a two-dimensional array of with each dimension equal to max nodes, that is the maximum number of vertices. So to reduce the memory consumption, or to solve this memory problem, we use an alternative representation of graphs using linked list, which is known as adjacency list representation. So in adjacency list representation, an array or vector of list stores edges between two vertices. The size of array is equal to number of vertices, that is n, and each index represents a specific vertex in the graph. So the entry at index I will represent the vertex I, and that array element will contain the pointer to the linked list, which will contain the vertices that are adjacent to I. Now, if there are n vertices in the graph, then we can create an array of list of the same size as adj underscore list of n. So let's see how it will look like. Suppose we have this undirected graph with 0, 1, 2, 3, 4, 5. So we start with 5 element array. This is our array where the index represents the nodes in the graph. So 0 is connected to 2 and 3. So 0 will point to, or rather contain, the list 2 and 3. 3 will point to null here. Now if you look at 1, 1 is connected to 2. So index 1 will contain only 2. If we look at 2, 2 is connected to 0, 1, 3, 4. That is every node. So 2 will point to 0, 1, 2, 1, 3, 4. Similarly, 3 will contain 0, 2, 4. Because 3 is connected to 0, 2, and 4. And 4 will point to 2 and 3. So that's how adjacency list is represented for undirected graph. And for directed graph, consider this graph which we have. 0 will point to 2 and 3. 1 will point to 2. 2 will point to 3 and 4. That is, only the outgoing direction is what we are keeping in here. 3 will point to 4 and 4 will point to null. So you may object that if we present using linked list, then the pointer which we need to maintain will consume 4 or 8 bytes extra, depending on the machine's word width. The logic is that if all these nodes are connected, suppose 0 is connected to every other node and 1 is connected to every other node, then adjacency matrix makes sense. But it is rarely the case that every node is connected to every other node. So the number of connections are very few compared to what is possible. And this is a very small graph. In a large graph, problem will be even more severe. The problem of memory consumption will be far more severe. The pointer is much less costly than what it appears to be. So with this, we now move on to breadth first search. So to do breadth first search, what we do is we maintain two arrays, or queues. The reached is a queue, visited is an array. So it's a Boolean array. So what we contain initially both are empty. So we start from the first node, which is 0. So when we visit 0, we mark 0 as visited and in the reached queue as well. Then we pop 0 and we see from 0 we have two edges. That is from the adjacency list, we traverse this list, we reach at 2 and 3. So we mark 2 and 3 as visited, reached here and visited. So after that we have 2 in the reached queue. So we look at the adjacency list again. From 2 we can go to 0, but 0 is already visited. 1 is not visited, so we put 1 in the visited table, and 3 is already visited. So we move on to 4. We see 4 is not visited, so we mark 4 as visited. Once we have done this, our visited nodes will be equal to the size of the graph, and we can immediately stop here because the full graph is explored now. At this moment, reached will contain 2, 3, 1, 4. Or for the sake of completion, you can actually go, if you don't want to rely on the length of this visited array, then you can go to reach and you can start popping 2. So from 2 we have visited the 2, so we pop this out, we go to 3. So we go to 3 and we see that from 3 we have 0, 2 and 4, but all are present in visited table. So we discard 3, we pop this out from this and we go to 1. From 1 we see we have already explored 2, so 1 is also popped, and we go to 4. From 4 we say we can go to 2, 3, but 2, 3 are present in the visited table, so this reached queue is empty, and then the algorithm stops. So if you want to find a node, so suppose we want to find 4 from the beginning. So once we explore 2, we see that there is a path from 2 to 4. So you can keep a track and you can figure out that from 0 we can reach 4. Now, there are certain properties of breadth first search. One is that it always returns optimal results. Second is that it is complete in nature. We will discuss further what is complete in nature in next video. I would have implemented breadth first search if we would have been programming in C++ or Java in this video only, because it is not a very complex algorithm. But since we are programming in C, we will have to implement a linked list and everything. So the implementation is slightly more involving. That's why I will implement it in the next video. So with this, I will end this video here. In the next video, we will implement breadth first search, and after that, we will implement depth first search. So stay tuned for next videos, and thanks a lot for watching the video. Feel free to subscribe the channel, like the video, share as much as you can, and make use of comment box. If you have any question to ask, or you want to give any suggestion, or you want to make a correction, and so on and so forth. So the reason for asking for subscription and liking is that I have become a full-time YouTuber, and I will keep on producing more and more videos. So if you like, share, subscribe, those kind of stuff, so it will motivate me. And second is that your actions like liking the video or subscribing will increase the reach of video to other students or professionals who want to learn about programming and maths in general. So those are the two reasons why I ask for this. In any case, thanks a lot for watching. Happy programming.